I was assigned problem 38 on homework 1. The problem reads, what is the force F on the 5 nanocoulomb charge in figure P25.38? Give your answer as a magnitude and an angle measured clockwise or counterclockwise. Specify which from the positive x-axis. The first thing I did was label each charge. I gave the 5 nanocoulomb charge Q1, 10 nanocoulomb charge I labeled as Q2, and the negative 10 nanocoulomb charge I labeled as Q3. The next thing I did was draw the force arrows. The force of 2 on 1, since they are both positive charges, they would repel each other, and the force would be going down in the negative y-axis. The force of 3 on 1, since they are opposite charges, they would attract each other, so the force would be towards the negative, and they would look like that. The next charge would be in this direction here. The next thing I did was write out an equation that I could use to solve this problem, and I wrote out F1 net would be equal to the force of 2 on 1, which is this here, 2 on 1, plus the force of 3 on 1, which is this force here. The next thing I did was write out all of my knowns and unknowns. Q1 labeled here as 5 nanocoulombs. Q2 is equal to 10 nanocoulombs. Q3 is equal to negative 10 nanocoulombs. R1, which is the distance between Q2 and Q1, is 4 centimeters. The distance R2, which is between Q2 and Q3, is 3 centimeters, and the distance between Q3 and Q1 is unknown as of now. The next thing I did was solve this part of the equation here, the force of 2 on 1. Since we know all of the values and we know the equation for the force, the equation is K Q1 Q2 over the distance between Q1 and Q2, which we labeled as R1 squared. We can plug in all of our values. We know that K is 8.99 times 10 to the negative 9 newtons per meters squared divided by coulombs squared multiplied by Q1 and Q2. Q1 is 5 nanocoulombs, but we have to convert that to coulombs by multiplying it by 10 to the negative 9. We do the same thing with Q2, 10 times 10 to the negative 9 coulombs, all over the distance between the two charges, which is 4 centimeters. We have to convert that to meters, which you do by multiplying it by 10 to the negative 2, and you have to square that. When we solve that, we get the force of 2 on 1 is equal to 2.8 times 10 to the negative 4 newtons, and because F of 2 on 1 is in the y direction, we can label it as J hat. The next thing we have to do is do the same thing, but solve for F of 3 on 1, but we don't know the distance between Q3 and Q1, so we have to solve for that first, and we can do that by using the Pythagorean theorem. So we have c squared is equal to a squared plus b squared. If you solve that out, you can get c is equal to the square root of a squared plus b squared. You plug in your values, and since we are looking between these two charges, these are our values, so this is a and this is b. So c is equal to the square root of 3 centimeters squared plus 4 centimeters squared all under the square root. C would equal 5 centimeters, and that C is our R3. So now we can use that to solve for the force of 3 on 1. We use the same equation as we did above, except that instead of using Q2, we use Q3 all over R3 squared, which is equal to 8.99 times 10 to the negative 9 newtons per meter squared divided by coulombs squared multiplied by 5.0 times 10 to the negative 9 coulombs by negative 10 times 10 to the negative 9 coulombs. You can see that there. Divided by 5.0 times 10 to the negative 2 meters squared. We solve that and we get the force of 3 on 1 is equal to 1.8 times 10 to the negative 4 newtons. The next thing we can do is solve for the components of the force of 3 on 1 because it is neither in the x direction or the y direction. So we have to solve for both components in order to add all components up to find the force of the net force on 1. And to do that, we can label this angle here as theta. And if we label that angle theta, we can solve for that angle because we know this distance as well as this distance. So if we do that, we have tangent of theta is equal to, tangent of theta is opposite over adjacent, so our opposite is 4 centimeters over our opposite of this angle theta is 4 centimeters and our adjacent is 3 centimeters. So it's tangent theta 4 centimeters over 3 centimeters. You solve for theta by taking the inverse tangent, so theta is equal to tan inverse of 4 over 3, and that gives us that theta is equal to 53.13. And we can use that angle now to solve for our components, our x and y components of the force of 3 on 1. So in order to do that, we will now solve for the x and y components of f of 3 on 1. So for our x component, we have, if we take a look back at the picture, here would be our x component, and this would be our y component here. Our x component would be cosine of theta, and our y component would be sine of theta. So if we do that, our x component, we just said, would be cosine. So our x component is cosine of theta is equal to the force of 3 on 1 in the x direction over the force of 3 on 1. We solve for this up here, so we have the force of 3 on 1 in the x direction is equal to the force of 3 on 1 times cosine theta. And theta is, we know this value and we know this value, so the force of 3 on 1 in the x direction is equal to 1.8 times 10 to the negative 4 newtons times cosine of 53.13 degrees. We can also solve for the y component. which is sine theta is equal to the force of 3 on 1 in the y direction over the force of 3 on 1 over the force of 3 on 1. And we can solve for the force of 3 on 1 in the y direction. Which is equal to the force of 3 on 1 times sine theta. And again, we know these values, so the force of 3 on 1 in the y direction is 1.8 times 10 to the negative 4 newtons times sine 53.13. This is our x direction, so it's our I hat. This is our y direction, so it's our j hat. The next thing we can do is add up all of these components, our x and y components of both the force of 2 on 1 and the force of 3 on 1 in order to find the force of the net force on 1. And we do this, so if we add up our x components, we have the force of 1 net x is equal to the force of 2 on 1 in the x direction plus the force of 3 on 1 in the x direction. We know that the force of 2 on 1 is only in the negative y direction, so there is no x component, so that's simply 0. And our force of 3 on 1 on x, we just solved up here, which is 1.8 times 10 to the negative 4 newtons cosine 53.13 I hat. So our net x is equal to that, 1.8 times 10 to the minus 4 newtons times cosine 53.13 I hat, which is equal to which is equal to 1.08 times 10 to the negative 4 I hat. We can add up our y's components, so it'd be the force of 2 on 1 in the y direction plus the force of 3 on 1 in the y direction. We know that this is in fact negative f of 2 on 1 because it's going in the negative y direction, and we found earlier that that value is it would be negative 2.81 times 10 to the negative 4 j hat plus the force of 3 on 1 in the y direction, which we just found earlier, which is this right here, 1.8, plus that value, 1.8 times 10 to the negative 4 newtons sine 53.13 j hat. If you solve that out, you get the force of 1 net in the y direction is equal to negative 1.37 times 10 to the negative 4 j hat newtons. I forgot my units here as well. And once you have both of those, you have your y component here, and you have your x component here. And because they are x and y components, and we're looking for the net force on 1, we have to use the Pythagorean theorem once again to find the net force on 1. And we can do that by plugging in all of our values. So the force on 1 would be equal to the square root of 1.08 times 10 to the negative 4 newtons squared plus 1.37 times 10 to the negative 4 newtons squared. And we get that f of 1 is equal to 1.7 times 10 to the negative 4 newtons. The last thing we have to do is solve for the angle, and that angle is this angle here. We solved for this force here by using the x and y component, the x and y components, and now we have to solve for this angle theta here, so, or our new angle. And to do that, we have to use tangent theta, and our tangent is opposite adjacent. Our opposite is our y, and our adjacent is our x. So we use tangent of our angle that we are solving for is equal to our y, which we solved for earlier as 1.37 times 10 to the negative 4 newtons, over our x, which is 1.08 times 10 to the negative 4 newtons. You get this angle is equal to the tangent inverse of 1.37 times 10 to the negative 4 newtons over 1.08 times 10 to the negative 4 newtons. And we get that this angle is 52 degrees. And it would be 52 degrees clockwise from the positive x-axis.